This is question number 1 of Qz8 for chapter 7. Florida corporations bonds maturing in 16 years pay 14% interest on a $1,000 face value. However, interest is paid semi-annually. If your required rate of return is 13%, what is the value of the bond? How would you answer change if the interest were paid annually? So I guess for me, it's always a convenience if I just put everything um, in the setup into my Excel worksheet. So I'm going to just do that. So the first number we are giving is the maturity years. So let me put that as 16. So remember, the number here represents the number of years. Why that matters? Because here it says the interest is paid semi-annually. So we need to ultimately work with the semi-annual numbers for each input. So pay 14% interest. So this is my coupon rate. Coupon rate is 14%. And par is 1,000. And the interest is paid semi-annually if your required rate of return is 13%. Right, so that's my using the notation that's should be K. K debt, that's 13%. So remember, by default, all these are coded in annual terms. So as we said, eventually we need to convert all these numbers, probably except for the par value, all these values into semi-annual numbers. So then we know that the value of the bond is simply the present value of all future cash flows, right? For a bond, the future cash flows include both the coupon, which is sort of an annuity, and the final par value or the principal value back. So that's a single cash flow. So the value of the bond is simply the present value equals PV in Excel, and open that. So the rate, as we said, this needs to be, rate is the discount rate. So that's the required rate of return. But here it's coded in annual terms, but we need this to be in semi-annual format. So we can divide this by 2. And the second argument here is the number of sort of the coupon payments. So we have the number of years. So we need to multiply that by 2 to get the number of semi-annuals. So that's the number of coupon payments. And the third argument here is the payment. So that is simply the coupon payment. Remember, the rule for this function in Excel and your financial calculator is that if you want to get a positive present value, then you need to have a negative payment and a negative future value. So we need to put a negative sign in front of this payment, and the payment is the coupon payment. So this is the coupon rate and times the par value. But this is the annual coupon payment, but we need the semi-annual coupon payment, so we need to divide this by 2. And finally, the future value, as we said, this also needs to be in negative format in order for us to have a positive present value. So negative future value here is the par value. So, and then we can close this. We don't have to worry about the last argument here, which is the type that represents whether the cash flows are paid at the end of the year or at the beginning of the year. By default, it's end of the year, so we don't have to worry about that argument. So we can just close it and go back to the rounding requirement. It asks us to round to the nearest cent. I guess it just happened to be the case because I rounded to 2 decimal places. If not, you can just format the cell and change that to be rounding to 2 decimal places. So let me just copy that number back, 1066.67, and then continue to the second part. If the interest is paid annually, the value of the bond is. First, before calculation, we need to understand the intuition should be that the more frequent the coupon is paid, the higher the bond value should be to us. And why that's the case? That's simply because of the time value of money. Right? The earlier you get the cash flow, the higher the value of that cash flows is to you. So that should be now if we change the interest to be paid annually rather than semi-annually, then the intuition should be the other way around. Then we should imagine the bond value should decrease relative to part A. So if we find the bond value actually increases, then and suggest to us that somewhere in our calculations perhaps we made a mistake or mistakes. So the V now, let me put the annual here, just to differentiate that from the V semi-annual we just calculated. So let me just put a semi-annual here just to separate that. So the calculation is similar. It's just now we don't have to convert all these inputs into semi-annual formats. And the first argument is still the discount rate, so we can directly use this 13%. And and the second argument is the NPER. So that represents the number of coupon payments. And since we have the annual coupon payment, so this is simply the number of years. And the payment is the coupon rate times the par value. And I also put a negative sign in front of that. And finally, the future value, we don't have to worry about this because that's a one single cash flow. And then you can see indeed this value is slightly lower than the value of the bond under semi-annual coupon payment. So that suggests that this might make sense. So it's 1066.04. Just double check. And now I can check my answer. It's correct.